Black holes devour everything, but can they be destroyed? What would happen if we pushed physics to its absolute limit? Could we break the universe in the process? Let's try it. See what happens. Let's make a black hole. Nothing crazy, just a small one about the size of our own moon. Then, let's nuke it. Big bangs destroy things, right? So let's just all agree to send our entire nuclear arsenal at this black hole. Sit back and see what happens. Boom. Black holes absorb everything that crosses their event horizon, all matter and all energy. Einstein's equation, E equals mc squared, says that any energy entering a black hole increases its mass. The mass of a black hole is proportional to its size. If we feed it with nukes, it'll grow each time. Matter and antimatter annihilate each other. So what happens if we toss some antimatter to the black hole? Well, when an object enters it, the black hole will completely annihilate any existence of it, no matter what it's made of. Black holes care about one thing: gravity. And gravity only depends on the total mass energy of an object. And the mass of a particle is the same as its corresponding antiparticle. So tossing in an anti-moon has the same effect as shooting a moon inside. The black hole just gets more massive. The ability of black holes to delete is super fascinating. It means regardless of their size and power, black holes are similar to elementary particles. These are the fundamental building blocks of matter and energy. They are particles, not made up of other particles. Elementary particles like electrons are incredibly simple objects. They can be fully described by just three numbers: their mass, spin, and charge. Black holes are also incredibly simple objects. They have a mass, they can rotate, and can carry an electric charge. Once a black hole forms, it doesn't matter what it was made of before. It could have been a star, an anti-star, or even a pineapple. It will always be fully described by those three numbers and nothing else. So if a black hole is basically just a weird particle, could we destroy it with an anti-black hole? The answer is no. Anti-black holes are hypothetical objects that have the same mass and charge as a black hole. If an anti-black hole collided with a black hole, they would annihilate each other, releasing a burst of energy. But the total mass energy of the universe would remain the same. A particle has the same mass as its corresponding antiparticle, but an opposite charge. Since a black hole has mass and an electric charge, its corresponding anti-black hole is expected to have the same mass and opposite electric charge. So if we make them collide, the charge will just add up and cancel out. After the collision, you'd be left with a new black hole twice as massive with no charge. Now, let's think bigger and broaden our horizons. In fact, let's just destroy the event horizon. Yes, a black hole can carry a spin and charge, but even black holes have their limits. If the spin or the charge of a black hole becomes too large, the event horizon begins to dissolve. If we simplify it, black holes hide a singularity inside. Here, it is thought to be where all the mass and energy of the black hole is concentrated. It is believed to be infinitely dense and have infinite curvature, and where the laws of physics as we know them begin to break down. That's why a black hole looks like a sphere of nothingness. The event horizon is the outer edge of the nothingness. Cross it, and you'll cease to exist in your current state. But when a black hole rotates, it works a bit like the spin cycle of a washing machine. Rotation inherently repels nearby objects and pushes them out of the black hole. But black holes do not allow this to happen because its gravity is so powerful. But if the rotation was able to get strong enough, the effect would win and the event horizon would disappear. But what kind of energy would be released in the process? Where would all that gravity go? Consider an electric charge. It's the same situation. Make it too big and the barrier would dissipate. If we somehow managed to remove the event horizon, the singularity would remain, and objects would still naturally pull towards it. And if you happen to be in the mix, you would still die horribly and quickly. But the vicinity of the singularity would no longer be inescapable. You could get as close as you wanted and then come right back. For all intents and purposes, that's the same as destroying the black hole. But how can we do this? One way to destroy the black hole is to overfeed it. All we'd need to do is overcharge or overspin the black hole. Just toss in a massive amount of objects of small mass but a lot of charge or angular momentum, so that the charge or spin increases faster than the mass. Fill it up like a balloon filling with water until it breaks. But the big physicist debate here is whether or not you can actually do this. Consider a charged black hole. Equal charges repel one another, and the more of the same charges you pack together, the more they push back. Say we have a negatively charged black hole, and we want to overfeed it with electrons, and whose charge is much greater than its mass. The electrons will have electrostatic repulsion, and again, the more electrons tossed in, the larger the negative charge of the black hole will be, and the stronger the repelling force. Once we reach that limit, the electrostatic repulsion will be so intense that it will no longer allow more electrons in. When you reach this point, the black hole will no longer allow itself to be fed. And with the spin, it's the same. When the black hole reaches its limit, the spin maxes out. However, some scientists think there might be a loophole. In an instantaneous moment, before the black hole reaches the limit, toss in the right amount of matter in just the right manner, and maybe, just maybe, you can overfeed it. Most scientists are skeptical that this can be done, but what if we can do this? What happens? There is one catch though. Remember, the event horizon of a black hole houses the singularity. By destroying the horizon, we'd just be left with a naked singularity that is no longer hidden. This is where the laws of physics as we know them begin to fall apart. Contrary to common belief, the singularity is not actually in the center of a black hole. Once something crosses the event horizon, aka the point of no return, that object is now in the future of everything else in the universe. The universe is so drastically warped by black holes that at the event horizon, space and time switch roles. When you cross it, falling towards the center means falling towards the future. That's why you can't escape. You can't stop your fall any more than you can stop time itself. It's impossible. The singularity is not actually in front of you as you might think, but it's in your future. And you can't see your own future in the same way you can't see the singularity until you hit it. And you can't really hit something that's in your future. Instead, you can only experience it when your next birthday happens. So, you'll feel the singularity once it happens to you, like a specific event in the passing of time occurring naturally in a given moment. This is not a problem because we can't even see or interact with the singularity anyways. But a naked singularity, no event horizon, would just be there, out in the open for us to see. What would you actually see? Well, that's impossible to say. A singularity is a region of infinite gravity. Gravity is the bending of space-time. The bending is so extreme that it rips apart the fabric of space-time. It is broken. Space and time cease to exist. Unless you're an oracle, you cannot predict anything. Nobody knows when and where something will occur. But now, where and when have lost their meaning. We are left with an unpredictable anomaly with infinite gravity and thus infinite energy. That literally means anything could come out of it at any time and for any reason. From a pile of pineapples or that one missing sock, or even an entire solar system. No predictability, no causality, and physics as we know them would be broken and unreliable. We think that singularities should exist because we think that we can prove that, in general, gravitational collapse leads to the formation of a singularity. But scientists think nature will simply not allow a naked singularity whatsoever. It's almost as if something has forced the event horizon into existence in order to prevent that chaos from infesting the rest of the universe. With no event horizons, physics would not matter. If you think about it, instead of black holes being seen as the ultimate monsters of chaos for the universe, they are actually the champions, keeping us safe. So, if we do manage to destroy the horizon, we also destroy the fundamental rules of the universe. So on second thought, let's just keep those nukes right where they are. As for now, there is only one thing we can do. Wait. Black holes emit tiny particles. This is called Hawking radiation. This process causes them to slowly lose mass until they eventually evaporate, leaving behind no horizon and no naked singularity. The time it takes this process depends entirely upon the mass of the object. As for our speck of dust, it will take over 1,000 years. So, is it possible to destroy a black hole? Yes, but I guess we'll just have to wait. Thanks for watching.